go ahead and jump into our notes today. Section 3 is just called trigonometry. Trigonometry is a special type of math that we do, and as we talked about at the beginning of class, when you look at your calculator, we're going to use these new terms called sine, cosine, and tangent. Before we can go ahead and jump in and start using that, in order to know how to use or which trig function to use, we need to know how we can talk about sides in terms of this triangle. So, in a right triangle, the side across from the right angle on the longest side is the hypotenuse. That's side C here. We know that term, we've had that term. Hopefully you're really used to picking out the hypotenuse. Hopefully you know it's our longest side and you know it's across from the right angle. That's not new. Now, in a right triangle, the side opposite a given angle does not share any sides with the angle. So we're going to talk about opposite side a lot today. So it's going to change based on what angle I'm looking at. Let's say I'm looking at angle A. I'm going to highlight angle A here. If I'm looking at angle A, I'm going to circle it here, then the opposite side is the side that does not get highlighted. That would be this little angle, or lowercase a there. Okay, so the side across from the angle you're talking about is the opposite. It's the side that does not get highlighted when you're talking about the angle. So if I say, hey, look at angle A, which side is opposite angle A? Then I would say side BC. Okay, and so I've got a hypotenuse, I've got an opposite side. The other side is what we call the adjacent side. So in a right triangle, the side adjacent to a given angle is a side of the angle that is never the hypotenuse, and it's touching that angle. So basically the remaining side is what we call adjacent. So if you look at a triangle, a right triangle, today we're going to only be talking about right triangles. First, you can identify the hypotenuse. Then, depending on which angle you're given, you're going to have an opposite side and adjacent side. So let's go ahead and take the same picture I have, and I'm going to change the angle. Okay. Now I'm going to say, hey, look at angle B. And we need to label our sides hypotenuse, opposite, and adjacent. Now, hypotenuse never changes. That's always going to be our longest side, always across from the right angle. So even though I changed my angle to be looking at angle B instead of angle A, my hypotenuse is still side AB. My opposite side is the side across from that angle. It's the side that does not get highlighted. So notice I highlighted angle B. Side AC then is my opposite because it is not highlighted. And then the remaining side is my adjacent side, side BC. Okay. Now, the last note about this before we go ahead and dig into our trig is that we never choose the right angle. I would never say, hey, look at angle C, look at that right angle, and identify the hypotenuse, the adjacent, and the opposite sides. We'll never say that. That does not work in a right angle trig. So, and the reason for that is because then opposite and hypotenuse would be the same, and that will never be the case. So we're going to look at either of the two acute angles. The side opposite it is what we call opposite. The side that's not the hypotenuse is what we call adjacent. Questions on those three terms? Okay, we'll get a lot of practice with identifying opposite, adjacent, and hypotenuse throughout. Now, here's what our key concept for this whole lesson is right here. Sine of an angle A. Oh, hang on, sorry, I had a question back up here. Okay, I'll scroll back up. Kira, what was your question? I don't know what you mean by cleared it. Erased it? All I erased was I just changed the picture around. If you can type it up, go for it. I'm going to go ahead and move on though, Kira, okay? So, sine of an angle is equal to the length of the hypotenuse, length of the opposite over the length of the hypotenuse. Cosine of an angle is equal to the length of the adjacent over the length of the hypotenuse. Tangent of an angle is equal to the length of the opposite side over the length of the adjacent side. So that's a lot going on, okay? It's a lot to remember. So to remember that, we actually abbreviate it. First, one abbreviation from what we have in the box here to what we have right here says sine of A equals opposite over hypotenuse, cosine of A equals adjacent over hypotenuse, and tangent of A equals opposite over adjacent. Now we even have a shorthand for that. We have a little saying that we do. But I do want to point out something quickly. Notice in the box, we've written out sine, cosine, and tangent. In the abbreviation, we did SIN, COS, and TAN, just like you see on the calculator that you have handy that we're going to use to do our trig functions here. Even though it looks like sin, cos, and tan, we never abbreviate actually how we say it. We abbreviate how we write it, but we don't abbreviate how we say it. And the reason for that being, it just sounds kind of funky. So even if I'm writing SIN, I'm still going to say sine, cosine, and tangent, never sin, cos, and tan. Now, here's our shorthand for this. So, ka, toa. And you've maybe heard that before. And this is how I write it. So, S, and then I write O over H. Ka, C, A over H. Toa, T, O over A. So, ka, toa. And I'll tell you what, I was writing this down on my paper all the way through my senior year of college. Probably about my senior year of college, I really had it memorized enough to where I didn't have to see it, to write it down. So if you were doing your homework, or when you're doing your homework, never feel bad to write this. In fact, when I was doing like tests and stuff, I would write it at the top of every single page. So, ka, toa. So, ka, toa. Just keep saying it over and over so you can remember it. If you can remember that, the rest of it should be pretty straightforward for you. Why is that important? I'm going to show you here in the whole rest of the lesson, Patrick. Hang on, Nakia, I see you have a question. Yes, very, very good question. Nakia said, or statement actually, she said, so notice in this key concept box here, it's talking about of angle A. Sine of A is equal to length of the opposite angle A over length B, sine, cosine B, and so forth. Excuse me, cosine A. Could that be the same if we replaced A with B? Absolutely. You can replace B, and then the difference would be your opposite and adjacent would change sides, but it would still work. So for example, let's look at A first. A is this angle here, and let's label our sides. Hypotenuse is always the longest side across from the right angle. Opposite is the side that is across from that angle we're looking at, and it does not get highlighted, and adjacent is my remaining side. Okay? So when I'm looking at A, sine of A is the opposite, so side BC, over the hypotenuse, side AB. We'll look at that more in depth in a second. Now, if I change it to be side B, sine of B, my whole picture changes. If I highlight B, side AB is still my hypotenuse, but my opposite side now becomes AC, and my adjacent side becomes BC. So these trig functions, trig ratios still work. You just change where your opposite and your adjacent are. Okay, so let's take a look at some examples. This is probably a little overwhelming for you right now, and I want to erase that because it only works for B. But let's look at some examples, and hopefully it will kind of start making a little more sense for you. Okay, because I know it's brand new. This might be the first time you ever see something completely brand new like this so far this year. So, problem 1. What are the sine, cosine, and tangent ratios for angle T? So it's important that we know which angle we're looking at. And if I was you, I would take out my highlighter and my colored pens, whatever it is, and the first thing I'm going to do is I'm going to highlight angle T. Vertex T, I highlighted the angle. The next thing I want to do is I'm going to identify, I'm going to label my 3 sides. Before I even look at sine, cosine, and tangent, I'm going to label my 3 sides as opposite, adjacent, and hypotenuse. So if you don't have these notes in front of you, hopefully you're at least taking notes. Draw this triangle, do a little sketch, label with me. Hypotenuse is across from the right angle. That's going to be this TG. Adjacent, let me do opposite first. Opposite is across from the angle I'm looking at. That's angle T. It's the side that does not get highlighted, making then the remaining highlighted side the adjacent side. Okay, now let's set up the sine, cosine, and tangent. To do that again, I'm just going to rewrite so, ka, toa. And if you'd prefer, you can just write it like this. If you don't want to write it as fractions, either way works. I've seen it done both ways. So how do we use that? Why is that important? Well, sine, always of an angle, of angle t, so sine of t is equal to, sine is opposite over hypotenuse. My opposite side has a length of 8 over my hypotenuse has a length of 17. So sine of angle t equals 8 over 17. Let's try setting up cosine. Cosine of angle t is, cosine is adjacent over hypotenuse. That's what A over H stands for. My adjacent side has a length of 15 over my hypotenuse, which is 17 again. And the last one, our tangent. Tangent of angle t, tangent stands for opposite over adjacent. My opposite side is a length of 8 over my adjacent side, which is a length of 15. Okay, so just take a minute and think about that. Okay, so ka toa. At this point, we're not actually finding the angle measure. I could. We'll use this in a minute. What do we use this for? Great question, Kiera. Why do we use this? Because I actually have a way to set this up, what I have right here, set these three things up, and then figure out what the angle measure for t is. We're just not getting there quite yet because we want to practice setting up our ratios first. Then we'll figure out how to actually find that angle measure. Okay, very good question. Let's look at one more. I'm going to have you guys work some of this out with me. So use a triangle in problem 1. So I've got the same triangle. I just redrew it down here. Notice it's the same triangle. And this time I want to set up sine, cosine, and tangent ratios for angle G. So same triangle. I'm changing the angle I'm looking at. I'm looking at angle G. Okay. Now I want you to tell me which side is the opposite side. You can either tell me the length of it or use the vertices. So is it TG, GR, or TR? Which side is the opposite side? And I see a question, hang on. Good question, Nakia. If the fractions can be simplified, should we simplify them? And for once, I'm actually going to say you don't have to. I normally would never say that. The reason it doesn't matter in this case is because when we actually go that next step to find that angle measure, you're typically not going to need to take the time to reduce the fraction. So very rarely are we just going to leave it in what we're doing here for problem 1. We're just practicing step 1. When we add step 2, it's not going to matter if we have a reduced fraction or not. Okay. Also, everyone who answered correctly. Very good. So here's my triangle, and I've highlighted angle G because that's the angle we're looking at. Opposite side is this side TR. Hypotenuse is same. That doesn't change ever. It's always across from the right angle, making then GR my adjacent side. So notice, if I go back up to the previous problem, the opposite and the adjacent have switched based on which angle I'm looking at. Now let's do the same thing. I'm going to do sine and cosine. I want you to set up, well, let me just start with that. Sine of G. Sine is opposite over hypotenuse. G is this angle here. Opposite is 15. Hypotenuse is 17. So sine of G equals 15 over 17. Cosine of G, cosine is the adjacent over the hypotenuse. Adjacent is 8 over hypotenuse is 17. What is tangent of G? You can just write the fraction. You don't need to write tangent of G. What is tangent of G? Remember, TOA. So, ka TOA. Very good. Everyone whose answers got it right. Keep going, though. What is tangent of G? TOA. Oh, I do have a few. Okay, hang on. Taryn, try that again. Austin, you're close. Try it again. Xavier, you're close. Try it again. Make sure you're looking at the right OA, opposite and adjacent. There we go, Taryn, better. So, tangent, TOA, opposite over adjacent. Here's angle G. My opposite side is 15 over the adjacent side is 8. Okay? So make sure you don't flip those. Now, side note here. Rule of thumb. No, not rule of thumb. Hard and fast rule. Always the case. When you're setting up your fractions for sine and cosine, the fraction you get will always be less than 1. In other words, your numerator should always be smaller than your denominator. If you were to turn that into a decimal, you should always get something less than 1. 8/17, 15/17, 15/17, 8/17. Those numbers, since your hypotenuse is on bottom, and your hypotenuse is always your largest side. The only time you should get a mixed number or a number larger than 1 will be for tangent sometimes. Okay, so tangent can go either way. It can be less than 1, it can be greater than 1. Sine and cosine will always be less than 1. So if you get a bigger number as your numerator for sine or cosine, bigger in your numerator than your denominator, then you have an error you'll need to fix. Okay, so let's keep going on. Why do we care about that? Well, we can actually use that and use our calculator to find angle measures using SOHCAHTOA. So it says in 1990, the Leaning Tower of Pisa was closed to the public due to safety concerns. The tower reopened in 2001 after a 10-year project to reduce its tilt from the vertical. Engineers' efforts were successful and resulted in a tilt of 5 degrees, reduced from 5.5 degrees. Suppose someone drops an object from the tower at a height of 150 feet. How far from the base of the tower will the object land? Round to the nearest foot. So there's a lot going on here, but what they've done is they set up a picture for us, and this picture is this yellow triangle, and what they're saying is, hey, this angle up here is 5 degrees. From where they dropped that item to the ground is 150 feet. We want to know, let me get a color, it's going to show up, how far from the base it is. We want to know this distance here, x. Okay, so I'm going to go ahead and I'm going to trace that angle that I know. Oh, I'm not actually, that's a big triangle to trace. Let's try without tracing it. If I look at this triangle, the side across from the right angle is that side that follows the building. So my hypotenuse is this length here. If I'm looking at this 5 degrees, the side opposite is the side I'm looking for. That's my x. And then this 150 feet becomes the adjacent. Okay. So I want to find x. I'm looking for the opposite. I'm going to go ahead and just, again, rewrite down SOHCAHTOA. So sometimes, unlike what we did in the last problem where we had all of the side lengths and we could use sine, cosine, and tangent, sometimes we have to pick out which trig function we're going to use based on the information we have and based on what we're looking for. So notice I don't know anything about the hypotenuse. I don't know the length of that. I don't know the length of the opposite side, but I know that's what I'm looking for. I do know the length of the adjacent side. It's 150 feet. So which trig function, sine, cosine, or tangent, am I going to use if I'm looking for the opposite side and I know the length of the adjacent side? Which trig function would I use? Go ahead and answer in the questions box if you know. If I'm looking for the opposite side and I know the adjacent. Very good. Everyone who's answered got it right so far. Yep, still good. Austin, try again. And Alex, try again. Which one am I looking for if I want opposite and adjacent? SOHCAHTOA. Which one uses opposite and adjacent? Luca, try again. Patrick, try again. Good, Courtney. Good, Xavier. Good, Ezekiel. Good, Jordan. Good, Alyssa. Okay. I'm looking for the opposite. I know the adjacent. Which one uses opposite and adjacent? Tangent is the only one that uses opposite and adjacent. A lot of you said cosine. Good start, because we do have adjacent, but I'm not looking for the hypotenuse. I don't care anything about the hypotenuse. I care about finding the side opposite. Okay, so good. So set up this picture, do this every time. You might need to write down SOHCAHTOA every time to identify which trig function you're going to need to use. So we're picking tangent. Now let's set up our tangent equation just like we did in the previous problems. Tangent, now the last time we would put in a variable here. We said tangent of t, tangent of g. This case, we actually know our angle measure. We know our angle measure is 5 degrees. So I'm going to say tangent of this angle, which is 5 degrees, is equal to opposite, I don't know, that's x, over adjacent, which is 150. Correct, Patrick. The one we were looking for is the one I marked with X down here. It wanted to know how far that object was from the base. So in this case, it was a story problem. Most of the time, and we'll see that in the next examples, it's just going to label one with a variable. Find X, find J, whatever it is. Okay. So questions on how I set this up here in the maroon. Tangent of the angle, which is 5, is equal to X over 150. Any questions on that? Now, that's not all I'm asked to find. I actually want to find X, and I actually can find X because tangent of 5 degrees is a number. So let's just start with that first. What number is it? Most of the time, they're going to be kind of nasty, irrational numbers, but I want you to practice finding tangent of 5. And calculators are going to do this a little bit differently. Some calculators, you put in tangent first, others you put in the 5. In my calculator, I click 5, tangent, and then it gives me my answer. So tangent of 5 is about 0.087. You practice that on your calculator. You should get what I get. Now, if you're in radians by accident, or see where I put rad, if you do, oops, that's not what I wanted to do. Tangent of 5, you get negative 3.3. So if you get negative 3.3, you're in the wrong mode. You've got to get to degrees. So whatever it is that you need to do to figure out how to get into degrees, where it says RAD, you should see degrees. On this calculator, remember there's that slide bar. On this calculator, tangent, first 5, then enter, 0.087. Okay, I'm not going to go ahead and take the time to make sure everybody did it and verify that you write it in the questions box or anything because we have more to get through, but hopefully you're getting that. If not, stick around after class and we'll go over that. So again, make sure you're in degrees. In this calculator, 5, tangent, 0.087. So that's a number. Typically, they'll be irrational. Some numbers will be whole numbers, but for the most part, they'll be long irrational. So we don't want to round that until the very, very end. Good, Kira. Good, good, good. So now let's say, hey, I want to solve this for X. To do that, I'm going to take tangent of 1 and make it a fraction by putting, tangent of 5, make it a fraction by putting it over 1. Anything can be a fraction, you just put it over 1. And now in order to solve for X, I'm going to use what we've been doing in the past chapter and cross multiply. So 1 times X is just X is equal to 150 times tangent of 5. Now you can write tangent of 5 times 150. In my mind, it's better to write the 150 first because then you know that it's not part of what you're taking tangent of, but you can set it however you want. So X is equal to 150 times tangent of 5. A couple ways you can do this. If you already had tangent of 5 in your calculator like I did, you can just multiply that by 150, and there's your answer. Or if you want to plug it all in at once, 150 times 5 tangent, then make sure you click enter. See both ways here. You can see in my history that I've done it 2 different orders. That's okay. Multiplication you can do in different orders, but I got the same answer as long as you click enter. Hopefully you're getting that. Now, our question says round to the nearest foot. So how far from the base of the Leaning Tower of Pisa was that object? It was about 13 feet. Okay. Always make sure your answer makes sense. I mean, in this case, sure, it's only a 5-degree tilt. That's not going to be that far, although 13 feet is still a long ways. But, you know, if we had gotten 1,300 feet, yeah, that's probably not right. We'd want to make sure we double check our work. So we've got 3 more of these we're going to set up. Actually, yeah, 3 more where we're working with them in this fashion. So we're going to keep practicing setting these up. So if you're completely lost, don't lose faith. Try to jump in here. First thing I'm going to do before I even look at my problem, I'm going to rewrite SOHCAHTOA at the top of my page. And obviously, if you're working on a single sheet of paper, you won't need to keep rewriting it, but I always want to have it within eyeshot. So for parts A through C, we want to find the value of W to the nearest tenth. Okay, so in this case, W is the side we're looking for. Looking at part A, I'm going to start by, oh wait, hang on, actually. Okay, yeah. Looking at part A. Now, we're not told, like we were in our problem 1, which angle to look at. In this case, we look at the angle we're given. Remember, we never choose the right angle. But I am given this angle here, kind of the upper left-hand corner, that 54 degrees. So that's the angle I'm going to look at. That's the angle I'm going to highlight. And before I do anything, I'm going to label my sides opposite, adjacent, and hypotenuse. The side that I didn't label or didn't highlight is my opposite. The side across from my right angle is my hypotenuse. The remaining side is my adjacent. Now, I need to decide which trig function I'm going to use. I'm looking for W, that's the opposite, and I've got to see what am I given. Notice the adjacent side here, this top side, I don't know the length of it. I do know the length of the hypotenuse. So I'm looking for the opposite, I know the hypotenuse. Which trig function, I just told you, uses opposite and hypotenuse? Sine, cosine, or tangent? Well, opposite and hypotenuse is only listed here for sine. So I'm going to pick sine, and I'm going to say sine of my angle. So my angle is 54. Sine of 54 equals the opposite side, which I don't know is just W, over the hypotenuse, which is 17. Sine of 54 equals opposite over hypotenuse, W over 17. Now let's solve that for W. If you need to, make sine of 54 a fraction by putting it over 1 and cross multiply. 1 times W is equal to 17 times sine of 54. Okay, and you need a calculator. You're not able to do these in your head. So make sure that you have a calculator. If you don't have one, find one, Google it, find it on your computer. Not quite, Nakia. So, I'll answer this in a second. I want to finish Nakia's question. So you choose which trig function, sine, cosine, or tangent. You choose that based on the two things. One should be what you're looking for. The other should be what you know. So you're going to choose it based on what you're looking for and what you know. So I'm looking for opposite because I'm looking for the side length W. I know the length of the hypotenuse. I don't know the length of the adjacent. I wasn't given that. So for example, if I try to use tangent, opposite over adjacent, well, opposite is W, adjacent is nothing. And we just have to put another variable there. And I wouldn't be able to solve it because I'd have two variables. Similarly, if I chose cosine, adjacent I don't know, so let's call that x, over the hypotenuse, well, it's going to find the adjacent for me, but I don't care about the adjacent, I want to know the opposite. Does that help answer your question, Nakia? Okay, Patrick, so the question is, if I don't know the adjacent, why'd I put 54? 54 is not referring to, and I can zoom in if that helps. 54 is not referring to that adjacent side. 54 is only the angle measure. It's not the adjacent side. 54 is the angle. Just like in part B, 28 is this angle right here. It's not this missing side. Does that answer your question, Patrick? Okay, so let's go ahead and finish this problem. 17 times sine of 54. So 17 times, in my case, I write 54 first, then sine, then enter. And let's round to the nearest tenth. That's what we're asked to. So we get about 13.8. Hopefully you're getting that. Okay. W equals 13.8. And you should double check with these. That length of that opposite side should be shorter than the hypotenuse because the hypotenuse is always our longest leg, our longest side. 13.8 is less than 17. That's just a good quick check. Okay, let's try B. I'm going to have you do more of it this time. B, I'm looking for W again. Which angle do I know? We never pick the right angle. I don't know the angle measure here in this right-hand corner. I know the bottom left. So I'm going to highlight the bottom left. I'm going to label my sides. It's always going to be the first thing that I do. The side I didn't label is my opposite. Side across from my right angle is my hypotenuse. The side to the left of that angle is adjacent. So now, what am I looking for? I want to know W. That's the adjacent. Actually, I want to pick a different color. And what do I know? Do I know the length of the hypotenuse? No, nothing is given for the hypotenuse for me. Do I know the length of the opposite side? I sure do. It's 1. 1.0. I don't know why they put the 0.0. So, which trig function am I going to use if I'm looking for the adjacent and I know the opposite? I almost said hypotenuse. That's not even a word. Which trig function am I going to use? Sine, cosine, or tangent if I'm looking for the adjacent side and I know the length of the opposite side? Very good. Everyone who's answered got it right. Excellent. You guys are making me so happy right now. Which one uses opposite and adjacent? Well, tangent does. Tangent is the only one that doesn't use the hypotenuse. So let's set up our trig function. Tangent of my angle, 28 degrees, equals opposite, which is 1, or you can put 1.0 if you want, over adjacent, which is W. Okay, now let's cross multiply to solve. Tangent of 28 over 1 if you want, cross multiply. Notice this one's a little bit different than the last two. The last two times I've had my variable in the numerator, now it's in the denominator. Not a big deal, just going to add one extra step. So if I cross multiply, I get W times tangent of 28 equals 1. Okay, now I want to get W by itself. And remember, tangent of 28 is just some number. It's an irrational, probably gross decimal, but it's just some number. So if I'm multiplying W times tangent of 28, to get W by itself, I need to divide by tangent of 28. So, oops, I went too far there, sorry. W is equal to 1 divided by tangent of 28. That would be an exact answer. Now let's go ahead and put that into our calculator and round to the nearest tenth. 1 divided by 28 tangent, enter. And you should get about 1.9. Hopefully everyone's practicing this in their calculator too as we go. So W is approximately 1.9. All right, last one like this before we move on to something new. Part C. All right, let's figure out what my side lengths are. Start by highlighting your angle. How do you highlight your angle? Pick the angle that you know the angle measure of that is not the 90-degree angle. I will do that in just a second, Taryn, okay? So there's my angles highlighted. Once your angle's highlighted, you can go ahead and label the side that's not highlighted as opposite. The side across from the right angle is your hypotenuse. And the side, the remaining side, I guess, is your adjacent. So without me saying anything, which trig function are we going to use? Sine, cosine, and tangent. Good, Kira. I like how all the exclamation points you include. It makes me excited. Kira's excited. Correct, Bethany. You highlight the angle that you know. Okay? Taryn, try again. Everybody else has gotten it right. Kira says this is fun. You guys are awesome. Nakia, try again. Everybody else is good so far. If I haven't said your name, you've got it right. Nakia, one more time. Bethany, try again. I love all the excitement we guys have. Okay, so let's look at what I have. Now, I've got this 33-degree angle highlighted because that's the angle I know the measure of, right? Okay, so this is the angle I'm given the measure of. That's how I know to highlight that angle. I didn't highlight this angle over here because I don't know the measure of it. I can't use it. It's not usable. I didn't highlight with the right angle because I will never, ever, ever choose the right angle. Now, let's look at what I want. I want W. W is my adjacent side. So I can tell you right away, since I want to find the adjacent, I'm not going to use sine because sine doesn't work with adjacent at all. Then, what else do I know? I know the length of the hypotenuse. It's 4.5. I don't know anything over here about the opposite. Nothing is given to me. I don't know its length. I don't know anything about it. I can't use it to help me find the adjacent. I do know the length of the hypotenuse. So which one uses adjacent and hypotenuse? Adjacent and hypotenuse is cosine. I'll underline just like I've done the other. So now let's set up our cosine function. Cosine of my angle, 33, is equal to adjacent, which is my variable, over my hypotenuse, which is 4.5. And I'm going to go ahead and finish this silently. I want you to practice it on your own. You don't have to type it if you don't want to, but try to see if you can solve this on your own without looking at my work. But I'll write my work down as I go. Oops, oops, oops. Don't watch that. Taryn, you had asked if I could put part B in my calculator again. So Taryn, if you want to go ahead and put your eyes up here, I'm going to go ahead and repeat part B in my calculator. Clear it out. 1 divided by, in my calculator, I have to put 28 first. Some calculators, you put tangent first. That just depends on your calculator. 28 tangent. And then notice what it's giving me right now is not my answer. That's just giving me what tangent of 28 is. We need to click enter to get our answer. So hopefully that helps. So if you just finished part C, if you're still working on it, you should get about 3.8. Now, we do have one last little part we need to make sure we get through, and we are running out of time, so I'm going to keep moving on. If you need help with any of what we've done so far, you have questions, A, you can stick around after class. I will have a little bit of time to go through some stuff. And B, you can rewatch this video, slow it down, pause it as much as you need to. Okay, now, remember back in problem 1, I'm even going to scroll up here quickly, where we were just setting up these trig ratios. And when you said, why do I care that sine of t is equal to 8 over 17? And I said, we can take that one step further. So that's step 1 that we did. If we do step 2, we can figure out what t is. We actually have a way to solve to figure out our angle measures. So all of this last part of the problems 2, we were finding side lengths. I can actually use SOHCAHTOA to find angle measures. It's going to be very similar. We're going to have one extra step in there, and that's using our inverse sine, cosine, and tangent functions. Okay, so before we even set up a problem, I want you to find that on your calculator. If you're using the calculator that I'm using, so it looks like this, there's this little up arrow right here. And if I click it and it turns purple, notice all of these buttons at the top just changed. So this is what they were before, now they changed. Notice now I have sine to the -1, cosine to the -1, and tangent to the -1. Those are called inverse functions. Inverse sine, inverse cosine, inverse tangent. If you're using a calculator on your smartphone, you probably have a button that says second somewhere. If it's not an arrow like that, it might say second. And when you click that, you should change your buttons. If you're using this Google calculator, you should click, I know it's on here somewhere. Maybe I need to clear. Maybe it's not on here. An actual calculator, it just depends. Lots of times it's either second, and then you'll see it written above the button. So if you see sine, typically above it, just written right on the calculator, it says inverse sine. So to get that, you need to click second and then sine. Thank you, Kirsten, found it for me. If I click right here, inverse, INV, notice that changes my functions. Thank you, Kirsten, for helping me find that. I knew it was on here somewhere because I've done it before. So if you're using the Google calculator, inverse. If you're using the calculator on your computer, the up arrow. Now let me actually show you here. If I pull this up here ever so quickly, oh, it's not there, it's here. Now this might not be exactly what your calculator looks like. This is a graphing one, but you might look similar to this if you're using a handheld calculator, which is a good thing to get in the habit of. This is just a picture of one, but to use inverse sine, cosine, tangent, I would click second, so this very up left-hand corner button that's in blue. Then I would click sine, and on my screen it would show up as sine with a -1 and a parenthesis. Okay, so if you're using a handheld one, even if it doesn't look exactly like this, that's probably the same process. Hit second and then sine. So let's everybody practice that quickly. No matter what calculator you're using, let's just practice, and let's do inverse sine of 3/5. Okay, so I'm on my calculator. Oh, shoot, I'm opening PowerPoint. Hang on. I'm going to click 3/5 first. 3/5 is 3 divided by 5. Enter. Then I'm going to click inverse sine. And I get about 36.9. Everybody should get that. Again, make sure you're in degrees. You might do a different order than me. If you have an actual handheld calculator, you're going to hit second, sine, and then 3 divided by 5. Okay, one more time. 3 divided by 5 first, 3/5 is 3 divided by 5, enter, then inverse sine, and there it is. Okay, we need to keep moving because I've got to get through this next point because it's really important, but we'll get it done. Okay, so let's practice. Find the measure of angle x to the nearest degree. So in this case, notice the only angle I know is that I have a right triangle, which remember, SOHCAHTOA only works on right triangles. So I'm not picking my angle based on the angle measure I know, like I did in the previous problem. In this case, I'm picking my angle based on what they're telling me, angle X. And I'm going to label what I know. This side length here, 6, is my opposite. This side length, 10, is my hypotenuse. I'm only labeling the two sides I know. I know the length of the hypotenuse and the opposite. So I need to pick out which trig function I'm going to use based on the fact that I know the side lengths of the opposite and the hypotenuse. Opposite and hypotenuse is sine. So part A, I'm going to set up sine of my angle. Now, unlike the last examples, I don't know the angle measure. I'm not going to put an angle in here. I'm going to put a variable, just like we did in the very beginning. Sine of x equals, opposite is 6 over 10. So I need to get x by itself. We don't divide by sine. That's not how trig functions work. I can't undo sine by dividing by it. I undo sine by using what's called the inverse function. So I can say x is equal to the inverse sine, or that sine to the -1, of 6/10. That's how you undo a trig function. That's how you get the variable by itself. So inverse sine of 6/10, just like we practiced in our calculator, it's actually the same thing. 6 divided by 10, enter, then inverse sine, about 36.9. Actually, it says to the nearest degree. So x is about 37 degrees. So very similar type of concept. Pick SOHCAHTOA, pick sine, cosine, and tangent based on what you know and the angle you're looking for. Now we're just adding that new step of using inverse sine. Let's look at part B. Again, I'm still looking for x. It's a different triangle, so now x is at the top. And let's label what I know. Well, opposite is mn, but I don't know the length of that side, so I'm not going to label that. 20 is my hypotenuse, 15 is my adjacent. So which trig function am I going to use? Which trig function uses adjacent and hypotenuse? Because I know the side lengths of the adjacent side and the hypotenuse. Excellent, you guys rock. We're going to pick cosine. And I'm going to set it up as cosine of my angle. In this case, I don't know. It's x. That's what I'm going to be looking for. Equals adjacent, which is 15, over hypotenuse, which is 20. Now again, don't cross multiply here, and I think that's where some kids get confused. If I have a number with my trig function, that's when I cross multiply. If my variable is inside that trig function, cosine of x, I have to use inverse trig functions to, like we say, undo, or to get the x by itself. So x is equal to the inverse cosine of 15 over 20. And Nakia, this kind of comes back to your question from the beginning of the class. Do we need to simplify those fractions? We don't, because it just adds time, and in this case, we're not looking for that. We're looking for the actual answer. So we can just plug it in as 15 over 20, enter, inverse cosine, about 41 degrees. X is equal to about 41 degrees. Okay, we've got one problem left, and then if we get to the attendance question, we will. If not, we don't. Okay, so, and then I'll go ahead and take any questions that we have. So use the figure at the right. What is the measure of angle y to the nearest degree? And then we'll look at part B. Let's see here. So part A, what is the measure of angle y? Here's angle y. Which sides do I know? Well, this is y. This 100 is my opposite. The hypotenuse is across the right angle. I don't know that. 41 is my adjacent. So which trig function am I going to use if I know the side lengths of my opposite and adjacent? Tangent, or TOA. So tangent of y, my variable is inside that trig function, equals opposite 100 over adjacent 41. So how do you get y by itself? Undo a trig function by taking the inverse. Inverse tangent of 100 over 41. Notice, my fraction did not change. It doesn't flip. It doesn't do anything. We're just taking the inverse tangent of that. Practice that in your calculator. I'm going to do it, but I'm not going to say it out loud so that you can check yours against mine. Good. Kira, I noticed you said that you got something different for the last one. Try it again. My guess is you just maybe had a calculator error because you should get the same one. Okay, so y is equal to about 68 degrees. So I just had a good question. When do you cross multiply? When do you use inverse trig functions? Very good question. Okay, Caitlin, stick around after class and I'll help you fix that. When do you cross multiply? When do you use inverse trig? If you know your angle measure and you're looking for a side length, that's what we did here in problem 2. In all of these, A, B, and C, I knew an angle, I was looking for a side length. So if you know an angle, you're looking for a side, then you use cross multiplication. If you're looking for a side length, you'll cross multiply. If you're trying to find an angle measure, like we did here in problem 3, excuse me, if you're looking for an angle measure, then you will if you're looking for an angle measure, you'll use inverse trig functions. Okay, better rule of thumb, so you don't have to memorize exactly that. If your variable is inside sine of x, cosine of x, my variable is inside there, that's when you have to use inverse trig to get it out. If your variable is just part of, it's standalone, it's just one of the parts, the numerator, the denominator, then you can cross multiply. And hopefully you could kind of figure it out by trial and error as well. If I come back here, if I were to try to cross multiply this, I'd get 10 times sine of x equals 6. Let me actually write that down here quick to maybe help you. 10 times sine of x equals 6. Not x, 10. And then I could divide by 10, and I'd get sine of x equals 6/10, and that's right back where I started. So even if you don't exactly remember, if you try to use inverse sine, if you try to use cross multiplication, you would see that it just doesn't work. It doesn't get you the answer. You're going to need to do one step further. Patrick, does that help answer your question? Okay, let's just do part B here quick. We'll just talk through it, and then we'll wrap up. So it says, suppose you know the lengths of all 3 sides of a right triangle. Doesn't matter which trig ratio you use to find the measure of any of the 3 angles. So if I knew all 3 side lengths and I was looking for an angle, I would know the opposite, the adjacent, and the hypotenuse. So if you know all 3 side lengths, you can pick any, so ca or toa, sine, cosine, or tangent, just as long as you're picking the right values to go in there. So just like we did in problem 1, where we were just setting up our trig functions, we could set it up for sine, cosine, and tangent for angle t. So any 3 of these functions here, if I found for t, would give me the same value. And let's do that quick. If I want to know what t is going to be equal to the inverse sine of 8/17. Well, let's figure out what that is. 8/17, enter, inverse sine. Oops, I went too far. Let me try it again, sorry. I'm trying to be quick here and I screw up. 8/7, oh, and I've got lots of stuff going on. 8/17, enter. 8 over, there we go. Inverse sine, about 28 degrees. So t is about 28 degrees when we use inverse sine. What happens if we use inverse cosine? Inverse cosine of 15/17. 15/17, enter, inverse cosine, about 28 degrees. Well, that's good because we should get the same angle measure no matter which trig function we do. If I do tangent, inverse tangent of 8/15, excuse me, 8/15, enter, inverse tangent, look, 28 degrees. So if you know all 3 side lengths, you can choose which you'd like to use, sine, cosine, or tangent, based on whichever you choose. All of them will give you the same thing as long as you're picking the right angles. Okay? So